Question number 1. If A comma B comma C are, if A comma B comma C are positive real numbers that satisfies the condition, positive real numbers that satisfies the condition A square plus B square plus C square is equals to 1. That satisfies the condition A square plus B square plus C square is equals to 1. Then find the minimum value of A square B square S is equals to this thing, A square B square by C square, B square C square by A square, C square A square by B square. This is the question. This is your question number 1. Solution. So in any question, if you observe this question, here A, B, C are what? Positive real numbers are given, and the question is of minimum. Whenever the given terms are positive terms and the question is being asked to find the minimum and maximum or minimum or maximum values, then you think of arithmetic mean is greater than or equal to geometric mean. So here ABC are positive is given and question is given, question is being asked to find the minimum value. So because AM is greater than or equal to GM is possible for positive real numbers. And one more thing is here, in arithmetic, when you use arithmetic mean is greater than or equal to geometric mean for two numbers, suppose A comma B are positive numbers. So arithmetic mean is what? A plus B by 2 is greater than or equals to square root AB. So if in question, if summation is given, that is constant, we can find the maximum value of the product. If A plus B is constant, we can find the maximum value of the product. If product is given as constant, we can find the minimum value of the sum. This one important thing. And come to this question. Suppose how to apply AM is greater than or equal to GM for this question means you take alpha square and beta square, two positive non-negative greater than or equal to 0. If you apply AM greater than GM for these two non-negative numbers, then what you get? AM, that is alpha square plus beta square by 2, this is AM, is greater than or equals to square root of alpha square beta square. That is alpha square plus beta square is greater than or equal to 2 alpha beta. Alpha square plus beta square is greater than or equal to 2 alpha beta. Now what you do is, now come to this question. Here S is equal to A square B square by C square and B square C square by A square. If you observe these two terms, now A, B, C are positive, therefore A, B by C, B, C by A both are positive only. So since A, B by C, let alpha is equal to here alpha is equal to, you consider A, B by C, let alpha is equals to A, B by C, and beta is equals to second one B, C by A. These two are positive since A, B, C are positive. Now if you replace alpha by A, B by C, beta by B, C by A, then what happens? A square B square by C square plus B square C square by A square is greater than or equals to 2 times alpha beta. Alpha beta means what? This AB by C into BC by A. Therefore A square B square by C square plus B square C square by A square is greater than or equals to, here A cancel, here C cancel. So this is what? 2B square, 2 times B square. Now similarly you take alpha is equal to that second term. Similarly you take alpha is equals to the second term, that is BC by A and CA by B. Then same apply this alpha square plus beta square is greater than or equal to 2 to alpha beta. Otherwise apply AM is greater than GM for alpha square beta square. So then similarly what you get, BC by A, CA by B. Similarly B square C square by A square plus C square A square by B square is greater than or equals to what you get, 2C square. I think you'll get 2C square here, 2B square, because BC by A into CA by B, BB cancel, AA cancel here, therefore you remain with 2C square. Okay, just one second. Yeah, 2C. Similarly if you apply AM is greater than GM for otherwise this result for AB by C and CA by B, AB by C, CA by B. Similarly AB by C, that is A square B square by C square, C square A square by B square is greater than or equals to 2 times what you get here, 2A square. Now our requirement is what, addition. Now add these two things, three things. This is 1, this is 2, this one is 3. Add both the sides, then what you get, A square B square by C square 2 times, B square C square by A square 2 times, C square A square by B square 2 times. That is 2 times A square B square by C square plus B square C square by A square plus C square A square by B square is greater than or equals to 2 times of A square plus B square plus C square. This 2 to cancel, but in question what is the given thing, A square plus B square plus C square is given as 1. So in question it is given that A square plus B square plus C square is 1. Since A square plus B square plus C square is equals to 1, then this becomes what, A square B square by C square plus B square plus C square by A square plus C square A square by B square is greater than or equals to 1. So what is our requirement? Some minimum value of this one. So what is the minimum value? 1 is the minimum value. So now the question is, when inequality is possible. So this is the minimum value. Additionally, if the question is when the equality is possible. In arithmetic mean is greater than geometric mean. When the equality is possible, A plus B by 2 is greater than or equals to square root AB. When equality holds, if A is equal to B. If A is equal to B, then what you get, A plus A by 2 is equals to square root of A square. That is A is equals to what, A. So when A is equal to B, then equality is possible. So here equality, when equality is possible, equality holds when all the terms are equal, that is AB by C is equals to BC by A is equals to CA by B. That is from these two things, what you get, A square B is equals to BC square. This B is not equal to 0, you can cancel because B is positive. In question it is given that, therefore A square equal to C square. So from these two things, B square C is equals to CA square. C is positive, therefore you can cancel. B square equal to A square. So from these two things, A square is equals to B square is equals to C square. When equality is possible, when A square, B square, C square all are equal, then equality is possible. So but in given condition is what, A square plus B square plus C square equal to 1, but all are equal. for equality, this explanation is for equality. When the equality is possible, means a square b square by c square plus b square c square by a square, c square a square b square equal to 1. When the summation is equals to 1. When summation is equals to 1, a square b square c square all are same. That is, a square plus b square plus c square is 1 is given. If you substitute this a square b square c square in this one, then what you get? 3a square is equals to 1. That is a square equal to what? 1 by 3. That is a is equals to what? Plus or minus 1 by root 3. But in question it is given that a is positive only. Therefore a is equal to 1 by root 3. So a, b, c are same. A square, b square, c square are equal. Therefore corresponding b is also 1 by root 3 and c is also 1 by root 3. Therefore when equality is possible, when a, b, c all are equal, and that too a is equal to 1 by root 3, b is equal to 1 by root 3, c is equal to 1 by root 3 simultaneously. So this is the solution for the first question.